zero exponents. So negative exponents, what we're going to do is we're going to evaluate the following expression, okay? So hands-on, okay? So we have to deal with exponent laws, okay? So if we have 2 to the exponent 3 over 2 to the exponent 4, what we're doing is we're using the division exponent law. So we're actually going to go 2 to the exponent 3 minus 4. We're going to take this exponent in the numerator and then subtract the exponent in the denominator, and we're able to do that because we have the same base. Okay, so we actually get 2 to the negative 1. Okay, and if we're focusing on the meaning of the powers, pretty much 2 to the exponent 3 actually means 2 times 2 times 2. And then we're going to put this over 2 to the exponent 4, which is actually writing it out 4 times. So this is a little bit of expanded form. Okay, so if we cancel these, we have, well, 1 over 2 left. Okay, so what is the value of 2 to the negative 1? Well, it's 1 over 2. Okay, so we have 2 to the negative 1, and it equals this. When there's nothing on top here, when everything's canceled out, it's not a 0, it's 1. Because 2 divided by 2 equals 1, so it cancels out to 1. Okay, so in general, when a non-zero base is raised to a negative exponent, the result is the reciprocal. So what this means is to flip it. Flip the number. Okay? And that means the numerator over the denominator. We flip it to the denominator over the numerator. Okay? So the result is the reciprocal of the base raised to the positive exponent. Okay? So if we have some base to a negative exponent, what we're going to do is we're going to flip it and raise it to the positive exponent. Okay, so in the next question, what we're going to do is we're going to rewrite each power as a power with a positive exponent. So 6 is also known as 6 over 1, raised to the negative 2. We're going to actually flip this, okay? So it becomes 1 over 6, and this entire number is raised, instead of to the negative 2, is going to be the positive 2. Okay, and this one just asks us to rewrite with a positive exponent. So we don't actually have to solve this. Okay, so we have 1/2 to the negative 3. So because this exponent is negative, let's flip the 1/2. It becomes 2 over 1. And it's raised, instead of to the negative 3, it's the positive 3. We don't actually have to write 2 over 1. We can just write 2 to the 3. Okay, and last one. This is also known, 8 is also known as 8 over 1, and it's raised to the negative 4. So in order to make this exponent positive, we're going to flip the numerator and the denominator, and then we're going to write it to the positive 4. Example 2. So this time we're actually going to go ahead and evaluate each of the following. So 7 to the negative 3, we can't evaluate an exponent when it's negative, so we flip the actual number, so 7 becomes 1 over 7, and this is raised to the exponent 3. Well, we know that this is also like saying 1 to the exponent 3 over 7 to the exponent 3. Okay, so when we do 7 to the exponent 3, we get 343. And 1 to the 3 is just 1 still. Okay, evaluate negative 5 to the negative 4. Let's flip this. So we're going to have negative 1 over 5 to the positive 4. So now if we were to like expand this just so that we can see what this looks like, it's going to be negative 1 over 5 times itself 4 times. So this helps us decide whether or not the number is going to be positive or negative. Since there are 4 of them, these 2 negatives will cancel out to a positive, and these 2 will cancel out to a positive. So we're going to get 1 over 625. Okay, now we have 1 over 3 to the negative 2. Let's flip this. 3, I'm not going to put over 1 because it's tedious. 3 squared, we know that's 9. Okay, this one's getting a little bit more complex. We have 1 over, okay, so this negative 1 is only assigned to the 5. So this is going to be 1 over 5. Now to the exponent 1. Okay, this fraction over fraction, it's really ugly. So what we're going to do is we're going to just rewrite this as 1 divided by 1 over 5. And just like in elementary school, this is 1 times the reciprocal. So I get the answer is 5. Okay, E, you get 2 to the negative 2 plus 3 to the negative 3. 2 to the negative 2, the number flips, it becomes 1/2 squared. Okay, that plus sign just comes down. 3 becomes 1/3, right? We flip it, and then it's a positive exponent. So 1 squared and 2 squared, I get 1 over 4. 1 cubed, and then 3 cubed, I believe it's 27. So if we go 1 over 27 plus 1 over 4, I get 31 over 108. Okay, last one here. 4 to the negative 2 becomes 1 over 4 squared. And then we're going to multiply it by, instead of 3, it's going to be 1/3 to the exponent 4. So 1 squared is 1, 4 squared is 16. We're going to multiply that by 1 to the exponent 4 is 1, 3 to the exponent 4 is 81. So all we're doing here is 16 times 81. We get 1296. So 1 over 1296. All right, let's talk about zero exponents. So we're going to evaluate the expressions using first exponent laws. So because we have the same base, what we can do is we can take the base and we're going to use division. Okay, and what we're going to do is we're going to subtract the exponent. So 3 minus 3, okay, we get 2 to the 0. Okay, what does that actually mean? Well, if we have 2 times 2 times 2 in the numerator, and then 2 times 2 times 2 in the denominator, these cancel to 1, these cancel to 1, and these cancel to 1. Okay, so what is the value of 2 to the 0? Well, it's 1. So the rule is, in general, when a non-zero number raises the exponent 0, the result is 1. And that's why I put anything to the exponent 0 equals 1. Okay, so we're going to go ahead and evaluate. 5 to the 0 equals 1. Okay, bracketed negative 8 to the 0 also equals 1. Okay, C is a little bit different. So we're going to bring down the negative sign. And the 0 is only attached to the 9. So this one's actually negative 1. Okay, so 4 to the 0 equals 1 plus, and then we have 4 to the negative 1, which is 1/4. So what's 1 1/4? I get 5/4. Okay, so we have 6 plus 2 here. I wouldn't even calculate that because I know brackets first, if it's raised to the exponent 0, this is just going to cancel to 1. So now we have 1 minus, okay, so 2 to the negative 3, we're going to flip the 2, which is 1/2 to the 3. So I get 1 minus, okay, 1 to the 3 is 1, 2 to the 3, 2 2 is 4, 4 4 6. Okay, so we have 1 minus 1 over 6, which is 5/6. Okay, and then a little bit different, if we have a fraction to the 0, still 1. Carbon-14 is a radioactive element that decays to half of its original mass after every 5,700 years. Okay, so awkward number, but It's okay. 5,700 years. And we're going to do by a half. Determine the remaining mass of 10 grams after this many years. Okay? So if you think about this, we have 10 grams. And, well, how many 5,700 year periods occurs in 11,400? Okay, so if we divide those, we actually get 2. So 2 half-lives or half-lives occur in 11,400 years. So what we're going to actually do is we are going to multiply 10 times a half times a half. Or in other words, 10 to the half squared. Or we could have written this 10 to the 2 to the negative 2. Okay, all of these here are equivalent. We can, all of these, so we'll put equal signs. Okay, so 10, a half of 10 is 5, and a half of 5 is 2.5. Okay, B, well, we have 28,500 years. So we want to know how many 5,700 year periods are in 28,500. So all we have to do is divide them, and we know that there are 5. Okay, so this time I'm going to just do 10 to the 1/2 to the exponent 5, and then just put it in my calculator. And I get 0.3125 grams. Okay, and then number 2, determine a value of x that makes each statement true. So x to the negative 3 equals 1/8. So why don't we flip this? So we have x to the negative 3 equals 8 to the negative 1, right? Because usually we would have to flip this, and then we can raise it to the negative 1. And then if we flip it, we raise it to a 1, right? Those are inverses of each other. Now we have to know what makes this. How can we get a 3 up here? Well, what to the negative 3 will be equal to 8. So if you think about this, 2 times 2 times 2, 2 and 2 is 4, 4 and 4 is 8, right? So if we have 2 to the negative 3, that would be equal. Okay, so in other words, x equals 2. Okay, x to the negative 1 equals 2/3. So let's get the 2/3 to the negative 1. Okay, so x to the negative 1 equals, we would flip that, so 3/2, and now instead of having a positive exponent, it would have a negative exponent. Okay, and remember, the exponent, when nothing's there, it's just 1. Okay, and if we see these two exponents are the same already, so x just equals 3/2. So all we did is we manipulated both sides to look like one another, and then that's what x would